So today we're going to go over how to procedurally make an isometric tower defense map using Astar. This is a work in progress still, but there's a lot to cover here, so we're just going to jump right in. So I have a video of an isometric tile map that I've used before, but I've decided that I don't like that as much as what I've done here, so I've made a brand new tile set with the same assets from Kenney. I'll put a link to the assets in the description. Now these are all individual tiles. And instead of using all of this extra space and then making a tool to do the offset, I'm just going to make the region be exactly the tile. And when the tiles are larger and say they have trees on them that go above this area, I'm just going to manually add those in and then use the texture offset to make them center. Now, if you're following along with your own project, make sure that you make this tile set exactly like this one, and it has to follow this diagram that I got from KidsCanCode. I'll put a link in the description, but later on in the video it's very important that these are in this exact order to make the code work. I've also added 16 and 17 in here, which are exactly the same picture as the blank tile or just the grass tile, and you cannot add the same picture to a tile set. It doesn't like that. So you actually have to go in here and click duplicate, and then you can rename it, and you can then add those same tiles to the tile set. And the reason why I did that is this one I added so I could modulate it to yellow. 17 I added so I can modulate it to dark. I did that to help me with debugging and to see exactly where things were happening. Now obviously the map is being produced procedurally in code, so there's nothing really in the tile map except for these tiles, which I just used as placeholders to show me exactly where things were being generated when I run the game. So the first thing that we're going to accomplish is we're going to make this rectangle. So since our tile map is isometric, that means that the x and y axis have been rotated, and that means that rectangles are actually pretty difficult to make. And so one of the things that's actually easy to follow is still the x-axis that will give us this angle. So what we're going to do is follow that x-axis here, and then we're going to add line by line until we have a right triangle, and then we can mirror all of these tiles and numbers over to the other side to finish it out and make the full rectangle. So to get that done, the only variable that we actually need right now is the onReady map. We're just going to get a reference to the tile map. That way we can shorten up the code and it's a little bit faster. We'll go over the rest of these variables as we need them. So we'll go to the ready function where we create the map, and we pass a number in there that's going to actually be the hypotenuse of that right triangle that I was talking about. This line right here is what I'm referring to as the hypotenuse, the line that follows along the x-axis. So we're going to take that hypotenuse, and the first thing that we're going to do is we're going to find the height. It's a little bit confusing, but x is still going to refer to the x-axis and this hypotenuse, and y is actually going to refer to this line here and how far we go down this side of this right triangle. And then for each loop, we have to figure out how long this line is, so each one of these is 2 less since we chopped 2 of them off. So this first one is 26, this next one's 24, and then 22, 20, and all the way down till we don't have any more in them. So how we accomplish that is as we loop through the height, we're going to find the length, and that's going to be the hypotenuse minus 2 times y. And after we find that length, we're going to loop through that and set the cell, so 15 is the empty grass. And when you look at this, it's x plus y, and that's a little bit different. If you did this the typical way of set cell y, x, y, this is what you'd end up with. Each time that we go down, we want to push this line of tiles down a couple, and how we accomplish that is adding the y, because the first time that we go through it, it's not going to move it at all because y will be 0, and then the second time it'll push it 1, and it'll just continually get a little bit bigger. That way we end up with this triangle that's here. Then after we're done making this triangle, like I said, we're going to have to mirror all of these tiles onto the other side. So I put this if statement here, if it's not 0. So the first time through we're going to do that hypotenuse, and if it's 0, we'd be looping through and setting all of the same cells to 15, so it's just unnecessary. So if it isn't 0, we're going to do the same x plus y, but it's going to be the negative y, which is going to mirror that triangle onto the other side. And again, if you don't have this plus y, this is what it will look like. So we have our original triangle here, except when it gets mirrored, it's not pushing all of these down like I was talking about. So we will add that back in. Since we're already looping through every single one of these tiles, it's a great time to set up our A-star, make all those points, and set up the connections between them. So before we look at the code for A-star, let's look at the variables that we're going to be using. We need an A-star node, so we need to create a new one. And then the top margin and the bottom margin, what those are talking about is when we loop through, I don't really want the map to be able to go up to these points up here. I want to have a little bit of a buffer zone. That way the map doesn't go to the very edges of the screen. Top margin and the bottom margin are going to be those buffer zones that the A-star won't actually touch, but we'll still have those tiles to kind of fill out and make a nice looking map around the edges. Now the starting point and the ending point is going to be where the path starts and ends. So we're going to pick a starting point and an ending point. Okay, so the A-star starts right here. Before we actually add an A-star point, we're going to check to make sure that we're not within the top or the bottom margin. Now the bottom margin, you have to minus it from the length. So the top margin is going to be referring to these buffer spots. And the bottom margin, you're going to always have to minus it from the length. So that way when it's looping through, when it gets to almost the end of the length that it's looping through, it'll know to stop. So we're going to make sure that it's within the margin, and then we're going to just get an available ID, and we're going to add that point to the current spot. And just for easier visualization, it's nice to keep the point in virtual space the same as the tile, so you want to make sure that the x plus y is happening exactly the same that the other one is. So this is still just doing the bottom right triangle. And so what this one is doing is it's connecting the previous tile. So when we connect points, that means that the path will be able to go along them. So this first chunk, we are just connecting the A-star points of the bottom right triangle that I've been referring to. And the difference between these if statements is, don't forget there's not an equal sign here, so this one will trigger one later than this one since it's not equal to, which is exactly what I want because I am going to connect the point previous. So we have x plus y minus 1. And so what that's looking at is, let's say we're going along here. Our margin is going to be 2, let's say. And so the first A-star point is going to be right here. When we go here, it's going to be greater than our margin. So then we're going to connect, or we're going to make a point here and connect to the one previous. So the first thing with the A-star is we're building this hypotenuse line, and we're just connecting the previous one in the line. We're not worrying about anything else yet. So then the next step is if it is not 0, so if we're not on the hypotenuse anymore, we're going to, first of all, also connect the lines towards the hypotenuse. So what we're doing is, so like again, this one is our first point, and we go along this hypotenuse. Then in the next line, this is going to be our first point, and we're going to connect it towards the hypotenuse. And what that looks like in code is we're going to do the x plus y, y minus 1. That'll bring us 1 closer to the hypotenuse. So take a look at the y right here. It's negative 1 right now. But when I'm going to this point and I minus 1 from y, it'll connect it to the tile that's right here, because that's 4, 0. This is 4, 1. I minus 1 from y, and I get this one. So I make that connection. So after I make that connection, I make another ID just to replace the current ID variable, and I'm going to add a point on the mirror side, or I'm going to mirror the A star points also, which again, when I was doing the hypotenuse isn't necessary because I've already have all of these points. I don't need to make a second line of points, which would just make everything confusing. After I add that point on the mirror side, I'm going to again connect those points in the opposite direction. So the negative y is the mirror part, and I'm going to add 1 to bring it back towards the hypotenuse. And this last line of code, just like how I needed to connect the previous one in the hypotenuse line, and I always connect backwards up this way, we're going to have to do that on the mirror side also, since we haven't done that. So we're going to make sure that we are not within the margin. So after we check, just like up here, we're going to connect with almost the same code, except it's on the mirror side, so we have a negative y. So just to recap what that code means is we're going to start on the hypotenuse within the margins, and we're going to make this line, and each time we're going to connect to the previous tile that we've placed. And then when we're done with the hypotenuse, going all the way down it, we're going to go to the bottom right triangle, and we're going to connect towards the hypotenuse and back to the previous one. And after we've done this line, we will mirror that action over here that will connect towards the hypotenuse, and then we will connect to the previous tile. So just a quick side note before we move on, I used these lines of code to help me debug everything that was going on to make sure that the A star was connecting to the right points. And so you can basically get the mouse position and put that into this function here with the A star of get the points. And when you run it, you can check to see what the tile is and which tiles it's connected to. Not to mention just reload the scene really quickly with just a click of a button. So after we've made all those connections, we have to pick a starting point. I also use the margins on this because I don't want my starting point to be way up here and in the corner. I think it'll just look better if it's at least partially in the middle. So again, we're going to find the offset, or how far down the map it's going to be, and we're going to pick a random number that's the height minus both of the top margin and the bottom margin, and then we'll add that top margin back on. Again, if you look up in this corner, if you look at this, when you move straight down, like the height or the y variable that I've been using, both of them move up the same. When you add 1 to y, you add 1 to the x, and vice versa. So when we have our starting point, it's the same offset. Now the ending point is going to be a little bit different. The hypotenuse minus 1 that's coming from when we loop through the length of the hypotenuse, it starts at 0. It won't actually be the length of the hypotenuse, it'll be the length hypotenuse minus 1. We're going to minus the ending offset, and then we're also going to have the ending offset be here. It's measuring from the top here, and it's measuring from the bottom here. So then, after we find the starting and ending point, we're going to go to the tile map, and we're going to set those cells to the dark black tile. That way, we can just see where they are. And this is mainly just for debugging and making sure things are working properly. Then we're going to take that starting point and that ending point, and we're going to find the A star ID that is associated with it, because that's what we're going to actually use to make the path. And once we have that information, we're ready to start the loop that's going to actually make the path that we want. If we just do a simple path, it will just draw a line straight across and basically be a super boring path. So what I did is these green tiles represent an obstacle that I've added to the map. So currently I only have 5, and we'll loop through this next portion of code 5 times to set an obstacle on the path. So the path wanted to go down in here, and I set this obstacle in its way, so then it had to go around. I set this obstacle in the way. There was no other way through, so it still can go through if it completely blocks everything. And then the path wanted to come down here, and this path got in the way. And I assumed that it wanted to go here, and so it had to go around that one and all the way till it gets here. And what that looks like in code is, like I said, we're going to loop through however many obstacles we have. we're going to get the path, which will return an array. Now this next line is a little bit extra. What it's doing is it's making sure that all the obstacles don't bunch up. So if you don't have that, it's very possible that all of the obstacles could bunch up in this first quarter of the map, and then it's just a lame path again. This way we're going to try and make one be in each section of the map. So basically what I'm doing is I'm taking the size of the path and I'm dividing it by the number of obstacles in the map. That way I can kind of section off the different areas. So then we're going to pick a point in each of the sections. So each time it loops through, it will find the path, it will partition it, it will pick a point in the partition. We're going to actually pick where the obstacle is going to go. And this is going to, so the first time this will be 0, and then we'll just have the point that's selected. But each loop, this number will go up and we'll push it to a later section, and we'll pick a point in that section. So these lines just help keep the obstacles from being at the very end and at the very beginning of the map. I don't want the obstacles to ever be on this line because it makes really ugly maps. After we've figured out exactly which point we're going to add the obstacle to, we're going to find it in the current path array, so along that path in the Astar. Then we're going to we're going to make that vertical line barrier. Now in the future I hope to experiment with different types of barriers and just different shapes to see if I can make more interesting maps, but basically I'm just looping through the size of the obstacle, which right now I have it at 5, and I'm going to mirror both above and below the point that we've picked to make that vertical line. Then we're going to find the ID of the point that's above or below the point that we found up here earlier, and we're going to change its weight scale to 5, just a large number. This is 500. So basically it's just a large number, but if it completely cuts off the path and there's no way around the barriers, then it will just go through. And then we will, this is just again for debugging, this is going to set that cell to that green tile so that way I can see exactly where they're going. It actually has to loop through and find that path multiple times because I want each obstacle to be on the current path. I don't want to just pick all of the obstacles on the first path, because if you remember, it would probably just be a boring path right here, and then it would just be a whole bunch of obstacles straight across the map, and it would probably just go around it. So each time it places an obstacle, it recalibrates the path from the starting to the ending point, and then it places the next obstacle. And then we get our final path. Right here, this is just so you can kind of see it in action. If you don't have this here, it won't turn them all black, and it won't do it frame by frame. As you can see like this, it does it frame by frame. And then, in the very last thing we're going to do is we're going to change all of them to roads, to the appropriate road tile. Now this is the part that I stole from KidsCanCode, and I'll put a link to his video because he explains it probably better than I will. But we're going to use a bitwise OR. What that means is we're going to do our calculation in binary. So these constants are what we're going to be working with. And I just added this at the end to show you what it would look like in binary. So what it's going to do when you use this bitwise OR, basically it adds all of these up to see if there is a 1 in that column. And so this would be 1, 1, 1, 1. If you added all of these together, you get 15, or in binary, it would be 1, 1, 1, 1. So we'll take this out so it doesn't give errors. Then we make a little dictionary that corresponds to the numbers here. If you remember, I told you you have to have the tiles in the specific order. So when we made our original rectangle, everything is going to be the grass, or tile 15, which is all of these added together. Then, for each tile in the path, so final path is that array of tile positions that we're going to loop through, and we're going to set its current tile to 15, or it'll be grass, and we're going to check in each direction. So we'll loop through it 4 times to see what the cell next to it is. And so this is getting the point on the path, and we're going to add the direction. So either a vector 2 of 0, 1, 1, 0, 0, -1, or -1, 0. And then if it is not the grass, or tile 15, we're going to minus that direction from the current tile. And what that means is, so let's say you have one that is, let's say we're adding 0, -1 to the tile, and we're going to see if there's a road there. And if there is a road there, it goes up here, and it looks at 0, -1, and it says, oh, that would be -1 because there's a road there. So it'll take it from 15 down to 14. And if we take a look at our tile set, number 14 is the one that has a connection to the north. So I have to check to see if it's grass, and if it's not grass, that means it's a road. But you have to also remember I have to add this extra check in here to make sure that it's not one of those green tiles that I added, because before I actually changed the roads, I added these obstacles to see what was going on. And so I don't want that to trigger changing the road, and that'll mess things up. So I have to check to see if it's not grass, and then I have to make sure it's also not this green tile. Eventually that line of code will come out because this is not going to be in the final product, but I need that for now. This is the point of the video where I'm just going to talk about what I plan on doing with this. Now obviously it has a long ways to go, but I think it has a lot of potential. I plan on playing around with the barriers or the obstacles to see if I can get more interesting maps, and maybe adding a few more waypoints in here to maybe make it go to a point up here and then a point here and then also end here. So just to make sure that there's a little bit more variety in the type of maps, and then we'll go ahead and try and make a tower defense game with it. But if you have any questions, since I did go through this pretty quickly, and I'm sure it's confusing, if you have any questions or comments, please let me know. If you like this type of video, definitely let me know.